Another important topic to talk about with probability is the concept of independent events. So, independence is when the occurrence of one event has absolutely no influence on the other event. So, if the probability of event A is not changed by whether or not B occurs, we would say that they're independent. So, you can test this by looking at the probability of A given B. If that's the case, if they truly are independent, you should still get the probability of A. So we have the special multiplication rule where the joint probability of A and B is equal to the probability of A times the probability of B. This only occurs when your events are completely disjoint from each other. Um, so remember, a joint probability is the likelihood that two or more events will happen at the same time. And so this special rule of multiplication is only going to refer to events that are independent. So here we have an example of the American Automobile Association. Here we have 60% of the members made airline reservations last year. Two of the members were selected at random, and we want to know what the probability of that both of them made an airline reservation last year. So we're assuming that these two members don't know each other. They're selected randomly. And so here we can say that these events are independent since whether one member made an airline reservation has no effect on whether or not the other member made the airline reservation. So here we can use the special rule of multiplication to figure this out. So if we take the probability that we have reservation from the first person and the probability of the second reservation, both being zero point 0.6, we end up with the probability of both of these events occurring as 0.36. Now, one of the things that we need to really talk about with this is making sure that we know that there's a difference between them being mutually exclusive and being independent. So remember, when we have two events with non-zero probabilities, cannot be both mutually exclusive and independent. So if one mutually exclusive event is known to occur, the other event can't occur because they're mutually exclusive. And so we have two events that are not mutually exclusive, might or might not be independent of each other. So just because they're not mutually exclusive, that doesn't mean that they're independent of each other. So one of the ways that you can test if they are independent of each other is you can look at the calculation of, does the joint probability of both things happen, or is that equal to the probability of each event happening on its own? So in our previous discussions, we calculated the joint probability of Markley Oil and Collins Mining being both profitable was 0.36. We also found that the probability of Markley Oil was 0.7 and the probability of Collins Mining being profitable was 0.48. So if we do the calculation of Markley Oil being profitable times the probability of Collins Mining being profitable, we get a value of 0.34. And when we calculated that joint probability in the past, we found that it was 0.36. So here we are able to conclude that these two values are not going to be independent of one another.